Okay, welcome back to Calculus 2. We are going to be looking at another integral here. This is a integral of dx over x squared times the square root of x squared plus 1. Again, if I'm looking to make a u substitution, I'm going to end up with a 2x somewhere. I don't have that anywhere out here. So you could start with that, but that's not going to work out too well. So if I wanted to say x squared plus 1, du is going to be 2x. We could try to do some other things, but this is not really helping out too much here. Um, don't let that stop you from trying different u's, because one technique would be to say u is equal to the square root of x squared plus 1, squaring both sides. So u squared is equal to x squared plus 1, and then taking the derivatives, we would have 2u du equals 2x dx, and then no plus 1 because it's a constant, and then trying to fit this into what's going on here. But that also doesn't happen. Okay, so this is definitely, you're going the wrong way. This is not going to work. But I know that a lot of times you substitution, like there's an obvious choice, you pick it, and when it doesn't work, you're like, well, I don't know what else to do. There's other things to do. Okay. In this case, though, because I'm looking at this shape down here, we have a square root of a squared thing. To me, that is screaming at you, do triangles. Okay. Now, normally I have to figure out like what side part of the triangle I'm dealing with. So I'll write down Pythagorean theorem just to make sure I've got the right shape here. I've got an x squared plus 1, I've got an a squared plus b squared equals c squared. Since there's a plus in it, I'm looking at picking my two sides, x and 1, so that my hypotenuse can be the square root of x squared plus 1. So if I had a minus, then I would pick one of the values that was, like c squared minus b squared. I would pick that for my hypotenuse. But this time there's a plus, I'm going to pick them as my sides. This guy over here, like, I don't know exactly where that's going to fit. We're going to follow the problem through. Maybe it comes out in the wash. Maybe it provides an extra little wrinkle, but we're just going to start with our first thought of making a triangle with my x squared and 1 here to see if we can't go ahead and do that. So I'm going to draw my little triangle over here. You can draw whatever triangle you'd like. Okay, make it a right triangle, but any triangle you want that's right. And we're going to go ahead and say that we want an x and a 1, and then this piece here is going to be my x squared plus 1. Now, the reason I made this side x was because my theta, actually, let's see here. I could make my tangent of theta is equal to x over 1, or we could say x equals tangent of theta. Now, if he didn't like that, we could have swapped the positions. We could have swapped and called the adjacent side the x and the opposite side the 1. The problem with that is when you take derivatives, that we're going to get cotangents, which are going to have negative signs in them. That's the only reason why. This is a choice that I made purely out of what's going to be convenient for me. If you didn't like how that worked out and you want to draw a different triangle and swap what the sides were called, you go right ahead and do that. That's not going to hurt anybody. Okay. So I've got my x is equal to the tangent of theta. So we're going to say that dx is equal to derivative of tangent, which of course is secant squared theta d theta. That's one of those that you kind of have to know. And that's kind of what we have here. All right. Now, what I'm going to do is I'm just going to rewrite my integral for a moment so I can substitute exactly. So we've got a dx times a 1 over x squared times a 1 over the square root of x squared plus 1. Okay, I just pulled apart, kind of like making an unconstructed sandwich or something like that. I just pulled all of these pieces apart so I kind of have an idea of what I actually want to do with this thing. When I'm looking at this 1 over x squared, that's an adjacent over opposite. That's a cotangent. So already I'm in a little bit of trouble, but we're going to call that cotangent of theta squared because it's one over x squared. As far as my 1 over x squared plus 1, well, adjacent over hypotenuse, that's going to be 1 over x squared plus 1. That's a cosine. So we have cosine of theta times cotangent squared. And then I have my dx. And what the heck is my dx? Is my secant squared theta d theta. So I'm going to say secant squared theta d theta, and that's going to be my integral. Now, going back to our trigonometric integrals, and I said, like, well, sometimes when you have, like, I don't really know what to do, and I've just got to mess with a whole bunch of trigonometric functions here. Turn it, just like with the trig identity, turn everything into sines and cosines, hope for the best. Okay, that's what we're going to do next year. So I'm going to integrate this. I'm going to say, okay, we have 1 over cosine squared, that's my secant squared, times cosine squared over sine squared, and then times cosine theta d theta. Well, that worked out a little bit nicer than I thought it would have, because look at this, the cosines cancel. Well, of course they do. This came out of a textbook. So here we have the integral of cosine theta over sine squared theta d theta. So at this point, I'm going to say, why don't we set u to be sine theta? My du is going to be cosine theta d theta. Here we go with the cosine theta d theta. That's just going to be du now. So I've got the integral of u to the negative 2, that's 1 over sine squared, and then cosine theta d theta, that's my du. Okay. Well, that's not too bad of an integral. I'm surprised it worked out to be quite so nice, but this is going to be, go ahead and add 1 to the exponent. So we have negative 1 u to the negative 1 power. So let's go ahead and figure out what that's going to be for us. So this is going to be negative 1. And then what's my u? U goes back to sine theta to the negative 1 power. That's 1 over sine plus c. Don't forget the plus c. So that's going to be negative 1 cosecant theta plus c. But this problem was originally posed to us in x's. If right, you go off and say hola to somebody and they start talking Spanish to you, you can't really blame them. You started it. Okay. I can't speak Spanish, so I would not say hola. I would say hey. And then that would be the way we would go for conversation. So we have to go back to x's. All right. So here we go. We have cosecant of theta. We're going to go all the way back to our triangle and figure out what the heck is a cosecant. Now remember, cosecant is 1 over sine. So it's hypotenuse over opposite. So this is going to be x squared plus 1, the square root of x squared plus 1, all over x. So we're going to say this is negative square root x squared plus 1, all over x, plus c, and that's our answer. Okay. So these can be a little bit tricky. Again, I know that the books and most of the YouTube presenters at this point just tell you to memorize the things and work their way through them. That is usually a simpler way to go about this. I was taught how to do it with the triangle and always go back to the triangle. So that's the way I'm teaching it, even though that's not in vogue right now. So yes, math has fashions too. So, we could do that. If anybody ever cared, you guys learned about law of sines and law of cosines. About 40 years before I took trig, they had a law of tangents. It still exists. We just don't teach it anymore. So things go in and out of fashion, things go in and out. So, but that's the answer to this. That's how you do it. Make sure you draw your triangle, label your sides correctly, and then pretty much you keep going back to this to kind of turn everything into thetas. And then once you have your integral set up, you go back to this and undo your thetas and turn them all back into x's. And that's how you do these. Thank you very much for watching. I'll see you in the next video and take care until then.